we will consider the following example. Square root of 115 should be approximated with precision epsilon equal to 10 to minus 3. Of course, that we don't reach this precision, you will reach using the algorithm during the lab. But now to sketch the first steps, we have square root of 115. So please tell me which are the nodes, the points that are considered.
121.
Right.
100.
Right.
144.
Good. It's enough. So you have given the points in the right order. It's not okay to take 100 and then 121 and then 144. So not in ascending order, but in this order are sorted with respect to distance to 115. The function, of course, is square root. So we look for perfect squares around 115. We already know that is recommended to take the points as close as possible to the point where we want to approximate, as the error depends on these distances. So these are the nodes. Then we have the value of the function for the nodes, which is 11. F10 is 10. F20 is 12. So we write the table. Now we need to find F11, and the 3 positions will have to be completed here: F21 and F22. So for F11, we have, please tell me the values. Xi minus xj is?
Minus 21.
Let's write 100 to be clear. 100 minus 121. And the first line?
11. 121 minus x.
X is 115. So we may replace it. Okay, next line.
10. And 100 minus 115. So minus 15.
Yes. So we have 1 over 21, as you already said. Here we have minus 165. And minus, here we have minus 6, right? Right. And the final result, please tell me which is what value you get.
5.
5? No.
10.71, I think.
Yes. 10.71 is minus 165 minus 60, so it's 200 and something. Maybe you have changed the sign to obtain 5. So 10.71. And this is right. As if you do the calculation for square root of 115, you get how much? 10 point.
10.72, yeah.
72. So we are close. Even from this step, from the first step, you see that we are close to the real value, just using 2 points. Then using another point, x2, we will get f21 and then f22. F21, I just write, we don't finish for this line. You will finish during the lab. So I is 2, j is 0. Here we have, please tell me the values.
1 over 144 minus 121.
Okay. And determinant?
Times 11, 121 minus 115. And the second line is 12 and 144 minus 115.
Okay. And we have some value there. It's necessary to write f21, to compute f21 in order to get f22. That is the value that we are interested in for this line. F22 is I equal to 1, j is equal, I is 2, j is 1. So we have 1 over x2 is, please tell me.
144 minus 100.
And the line?
We have 12. 144 minus.
Pay attention, is f11.
Oh, okay. Sorry.
So is what we have already obtained is 10.71. And now xj minus x is, x1 is
100, no.
100. 100, I think is, right?
Yeah,
the second
100
point.
minus 115.
This is it. Then for the second line, we have f21 that should be previously computed, and then we have xi, which is 144 minus 115. And you will see that after you compute this value, you will get a better approximation than the previous one, than f11. You have to check if f22 minus f11 in absolute value is less than epsilon. If this is fulfilled, then f22 will be the approximation. If not, we will type the message, give more points, and you will give more points in order to continue. So this was Aitken algorithm, an algorithm that is used for finding Lagrange polynomial. Next, we will see another method for finding Lagrange polynomial, for solving a Lagrange type problem. Namely, for finding a polynomial that approximates the function when we know some information, some values of the function for a set of points. The following algorithm gives a form of the polynomial with respect to divided differences. You will see that we will use a lot divided differences for this part, for this chapter of approximating functions. So this form is called Newton's form. The polynomial is a Lagrange polynomial in Newton form, or just Newton polynomial. So Lagrange polynomial in Newton's form or just Newton interpolation polynomial. We may denote the polynomial as we have denoted for the classical form using LMF, or there exists also the notation for this form as NMF from Newton, as you wish. Both of them are used. So LMF equal to NMF is, if you wish, you may denote by N, is given by f of x0 plus sum I from 1 to m x minus x0 x minus xi minus 1 multiplied with divided difference of ith order at the point x0. So this is the form of the polynomial using divided differences. This DIF at x0 denotes divided difference at the point x0. Divided difference of I order. This can be also denoted, this divided difference, DIF of x0, can be denoted with square brackets and showing the points x0 till xi for the function f. It is useful here to know also this notation, because you will see in order to find the formula, we will use this notation to see the nodes that are used for each divided difference. So these notations are similar, denotes divided difference of I order at x0 that uses the points x0, x1 till xi. This form Newton interpolation polynomial or Lagrange polynomial in Newton's form. How it is obtained, this polynomial? We will sketch a way of obtaining the polynomial. We base on the table of divided difference. I recall that divided differences table looks like this. We have as first column the point, second column values of the function for the points, and then we have first degree divided differences, second degree, and so on till m degree. We add a point at the beginning. So for the first element, we consider the point x where we want to approximate the polynomial, where we want to approximate the function. So we add x and then we put the other given points. For x, value of the function is f of x, and we have divided difference for the point x equal to, which is divided differences that uses x, x0. So using this notation, we have the divided difference that uses x0 and x. And you know that its value is f of x0 minus f of x divided to x0 minus x. For this column, you know that we have to look at the previous column, next line minus the current line, over xi plus 1 minus xi. So for this divided difference, we have f of x0 minus f of x over x0 minus x. And we write f of x from this. F of x will be f of x0 plus x minus x0 x0 f. We find f of x0 from this identity and we get this. We continue, and if we write second order divided difference at the point x, what should be here? Where is the max? So second order divided difference is the first element from the next column. Is given by previous divided difference, previous column, next line, minus previous column, the current line, divided to x1 minus x. We skip an element here. So we have that divided difference that uses x, x0, x1, and f is given by x, x0, x1, f minus x, x0, f over x1 minus x. From this, we will find divided difference x, x0, f, first order divided difference at x will be x0, x1, f plus x minus x0, x1. And second order x, x0, x1, f. We replace this in the first equation where we had f of x. So we replace 3 into, we replace this divided difference of first order